be something in here for you. A lot of it is just sort of common sense, but I feel like it's a lot of common sense from a lot of different disciplines that very rarely get sort of consolidated together. So I just kind of wanted to pull everything together and give you guys a walkthrough. So about me, technically I'm a security engineer. I work for the University of Pennsylvania, which is one of the larger schools in the United States, down in the state of Pennsylvania, in the city of Philadelphia. I started my career as a web application developer though, so I've always been interested in security, but I started my professional life building websites and building web applications for people, which I think has been really helpful for me moving to web application security because I understand frustrations that people have about just trying to push features and getting things to work. And I understand that oftentimes the security people are just a nag, and it tends to get in the way of productivity and can be problematic. And so some of the strategies I'm going to present here are a way to sort of like get away from the nagging security person trying to tell you you're doing it wrong here, you're doing it wrong here, you're doing it wrong there. I'm also one of the chapter leaders in the Philadelphia OWASP, and we meet semi-regularly. So hello from Philadelphia OWASP. Official diplomatic slide. So I sort of like thought about the title of this presentation for a little while, and then it occurred to me that I'm kind of lying to you right off the bat because I pulled together this title like Proven Strategies for Web Application Security because it sounds really good, but the reality is if security works, nothing happens, and you can't prove a negative. So I don't actually have any proven strategies. I have strategies that resulted in a strong correlation in my environment. So bear that in mind. I'm not giving you any silver bullets here. This is something that seemed to work for me. I don't have any empirical evidence that it actually did. All I can do is say, in my environment, we observed a precipitous drop in security incidents after implementing a lot of these strategies. And so what I'll try and do, in terms of the format of the presentation, is talk a little bit about sort of a specific aspect of application security or infrastructure security or application development, its relationship with security, and potential strategies that you might be able to pursue to increase the security posture of your organization. And then I'll actually provide you concrete examples of like stuff that my organization actually did, in case you're sort of like, you know, that's helpful and all to give me some guidelines, but like give me some URLs, tell me some tools. I want some actual like concrete bullet points, and so I threw those in there as well. This approach worked really well for my organization. Your mileage may vary. Some of the stuff I talk about may not be possible for you. Everybody's organization is different, and so some of these strategies just might not be feasible. They might not fit into your infrastructure. You might not have the staff, you might not have the talent, you might not have the resources, you know. Be comfortable understanding that like you don't have to apply all of these things to get positive results. Even just one or two is definitely going to move the bar forward. So when talking about web application security, it's really important to discuss why web apps are such a problem these days. And I think for anybody that builds web apps, it's kind of flattering to know that like the stuff that I build is like the #1 target on the planet at this point. Like it's no longer Microsoft Office or Adobe Reader or anything, even though they still get the headlines. The problem with web applications, right, is we've changed the way we develop software. As software developers, you used to develop packaged software, right? You'd have an installer, and you'd deliver it to a customer, and they'd pull it to their desktop, and they'd install it, configure it on the desktop, and boom, you're done. If you needed some networking, you might open a port to maybe communicate to another service, but your install was very targeted. You're pushing software to specific users, right? In many ways, the mobile realm kind of mimics this. You build something in a place, and the user grabs it and pulls it onto their local device, and then they have it. They're responsible for it. There's advantages and disadvantages in that model, right? Like it's tough to do updates in that model because you can't do updates in the cloud. It's not necessarily as agile. You can't change things on an end user's machine once they have it. You don't necessarily have reliable networking, so on and so forth. And so a lot of application developers began taking their traditional desktop application and migrating it to the web. And the web has a lot of advantages. The first is that it's easy to get to from anywhere, right? The only client software you need is a web browser, which makes it almost universally accessible. It is going to run off a standard port, port 80, and firewall admins 10, 20 years ago suddenly realized there was an explosion of applications on their network, and most of those applications used specific ports tied to the applications, and they almost got overzealous and just started locking everything down. And the one thing they didn't lock down was the web. And so, for whatever reason, Port 80 and port 443 in the web have become de facto content delivery mechanisms. So now it's very easy to stand up an application in HTTP or HTTPS and evade any of the perimeter rules that security is sort of throwing up around organizations. So we have this situation where we're deploying applications that can be accessed from anywhere by virtually anyone with no specialized tools, right? All they need is a web browser, and everybody who has a phone has got a web browser on that. Now we're going to have web browsers in our refrigerators. And we're putting these online 24/7, right? So your application is not just servicing your clients, it's servicing whoever happens to come by, whenever they happen to come by, and that quite frequently is when you're not around and nobody's paying attention. Not only that, with the explosion of web applications, more and more of our sort of daily lives and commerce are occurring over the web, right? We buy things over the web, we bank over the web, we manage our retirement savings over the web. Like, there's a lot of economic value in the web, and what's happening with that trend is that the browser is actually gaining in value for an attacker, right? So if I'm an attacker and I want to take over your machine and I want to steal money from you, let's say, I could try and take over your operating system, but operating systems have gotten pretty robust and pretty good about defending themselves at this point, and that's kind of a hassle. But I don't actually want to take over your operating system to get your money anyway. What I want to do is take over your operating system so I can get access to your browser, right? So that I can steal your usernames and passwords and your one-time tokens as you're doing your banking transactions, modify them on the wire, and get you to ship all your money off to somewhere else. If I can actually just attack a web application and get a foothold in a browser, that in many ways it's much more damaging for the attacker, and it's also much easier. Sadly, it's very easy to find holes in web applications, and once an attacker can find a hole in one web application, they can usually use that toehold to sort of leverage and extend their control over the browser. And we see cases today where attackers actually don't even bother to try and attack the operating system. They're totally satisfied compromising end-user browsers, and that's really all they want. So, in the face of this kind of threat, what can we do, right? Knowing that we're basically deploying all our applications into this hostile environment full of bad guys who are going to want to attack them in ways that we hadn't even thought about, what can we possibly do to make sure that we're protecting ourselves, protecting our infrastructure, and protecting our clients? And there's a number of different things to do. The first thing that I would say is to choose a standard. And this is a little bit antithetical to sort of the creative work that a lot of web developers do, right? You find a cool technology, you play with it, you deploy it, you run it, you say, hey, this works, nah, this doesn't work. You're like, oh, have you heard of Node.js? Let's stand up an app in that, and let's see how it pans out. Standardizing on your platform means sort of choosing a standard build platform, and by that I mean like a whole stack, everything from your programming language to all the way down to your operating system, and sticking with it. And it's somewhat boring, but what you get as a trade-off to sort of this like boring standard is you get a really good, you get to maximize the potential of all of your people, right? People become very familiar with the infrastructure, they know what to expect, they'll explore all its nooks and crannies, and then you'll have a confidence that when you deploy new applications into this infrastructure, that you've looked at all of sort of the ancillary aspects of this infrastructure, right? If, on the other hand, you're sort of like deploying, Node.js server over here, and maybe a Tomcat server over here, maybe you got some Oracle databases in one place, some MySQL databases over here, some Python, some Django running. The people who are managing those apps are really just they're getting forced into the role of being novices in all of them, right? They might sort of understand the security impacts and the interconnections between all those systems, but they're never really going to be masters of any particular one. You may get a lot of resistance trying to force people into a specific technology sort of, vertical, but you get a lot of win. When people work with the technology day in and day out, they develop a mastery that they really just can't if they're switching from technology to technology. So we always tell people, choose a standard. It doesn't matter what you choose. There's not necessarily anything that's better or worse. The advantage you get out of choosing a standard is just you develop a breadth of knowledge that you can apply to all of your projects. The next most important thing that you can do after you choose a standard is to choose a framework. Going the wrong way. Yep. There you go. So, if there's anybody here who still thinks that like when you design a web application, you pull up PHP and you start typing, and that's the way that you should be developing your web applications, I hate to inform you that time has passed. I think those days were fun, but they're gone now. I think web applications are far too valuable and they're far too complex for people to be coding them all by themselves. Not only that, but you do that once or twice and you realize you're reinventing the wheel, right? Like as soon as you start coding up your user authentication piece of your website, you're doing something that somebody else did. And probably something that somebody else did, you spent a lot longer at it than you did. There's no sense in not utilizing those resources. And so you really need to sort of pick your choice of web application development framework and learn it and utilize it to its maximum extent. We sort of recommend you choose a couple, right? Because you might find some application platforms, some frameworks work well in some instances and some work really well in other instances. But just like standardizing on a platform, you don't want to choose all of them and say, like, let's just choose a platform. You want to be a little bit judicious when you're sort of thinking about your frameworks as well, because every single programming language has its own security challenges, and every single framework implements and addresses those challenges in different ways. So you want to make sure when you're evaluating frameworks, you have some sort of standard set of questions that you're asking of all the frameworks. You want to basically say, you know, like, does this platform release updates? Is this platform something that's like really cool now, but it could die tomorrow? Do I actually want to invest in building my applications on them? You want to understand, is the platform actually implementing security countermeasures? So CodeIgniter is a super popular platform that I had on the last slide that I get a lot of people asking me to use. And CodeIgniter is great, but it fails because it doesn't implement several critical security countermeasures by default. It's not that they're not there, it's just that the developer has to remember to implement them every single time they do something, which sort of defeats the purpose of the platform, and I'll sort of talk about that a little bit. In addition, you want to make sure that whatever framework you choose is conducive to an environment where you can do sort of staged development and actually do some security testing before you roll your applications out the door. Some applications are friendlier at doing that than others, and you want to make sure that if they have options to use safe libraries, that you basically force the frameworks to use those choice libraries. So when you're trying to figure out, well, what do I pick, right? So there's a laundry list of stuff. You can go to any sort of major website, and they'll give you, like, these are the top 50 frameworks that folks are using. These are some of the questions that we actually considered in our environment. We sort of thought about, how well does that technology mesh with ours? Like, we had one customer who was just advocating Plone. They were like, Plone is the coolest thing ever. And the more research we did into Plone, the more his claims actually stood up. It was a very solid platform. It worked really well. But it was all implemented in Python, and we didn't have any Python programmers on staff. And so we instantly recognized, look, we could develop an application in this technology, but as soon as the consultants who build the application leave, we can't support it. Like, one thing goes wrong, and we're dependent on the consultants who are eventually going to get tired and move off anyway. So do we really want to sort of like saddle ourselves with this kind of a project forever, potentially, and watch it just slowly degrade? So we nixed that. You want to make sure that whatever framework you look at actually has a security team, or at least some mention of security on their website. If there is no mention of a security team, a security response, a security contact, that's a terrible sign, because that means anybody out there who's just looking to make a name for themselves by finding holes in frameworks, if they find a hole in this framework, they're not going to have anybody to contact, they're not going to have anybody to coordinate with, there's not going to be any established flow to resolve the vulnerability, fix it, push a new patch. And so you could wind up choosing a framework where vulnerabilities could just get published publicly. And suddenly everybody who wants to attack your framework knows about these problems with it, and you're stuck without any support from the actual manufacturer. The other thing that you want is good long-term support. So flash-in-the-pan frameworks or technologies that show up right now and seem really cool, be very careful of those, right? So like any technology, web application frameworks really sort of show their value under intense scrutiny from security researchers. So you really want to choose something that's been out in the field for a little while that people have had a chance to hammer on. So it's a little bit like, I hate the Gartner Magic Quadrant where they sort of rank it like these are your safe picks, but you kind of want to do that. You kind of want to look at what other people are using and how long they've been using, what sort of problems they've been having, and settle on something that you're going to feel comfortable with. Availability of local talent is huge. So when we sort of look at technologies, even if we have a bunch of people in-house trained in that technology, we always sort of do the mental exercise, well, what if they're all on the same bus and it goes over a cliff? Then what do we do? And we've had like just terrible circumstances where entire departments have suddenly become unavailable. So it's important to think like, okay, if you really want to do like Ruby on Rails, are there people in Montreal who do Ruby on Rails? Like, what are their consulting fees like? Are they reputable? How easy would it be to engage them to finish a project if something went wrong? Looking for published material is usually good, like trying to find books. That's just a good benchmark for the maturity of a particular technology. If there's no published books on a technology, it's super young, and it might not be ready for prime time. And then lastly, the overall lifespan of the product. And sometimes you'll see products that have like a really good 5-year lifespan that ended in like 2007. And you want to consider that as well. Like it needs to be an ongoing lifespan. So to sort of give you a good visual for the benefit of the framework, and I'm not sure how many people are familiar with this. I'm not sure how many people are familiar with this graphic. So this is the OWASP periodic table of vulnerabilities. Has anybody in the room seen this before? A couple of people. Yeah. Wow. Awesome. So I saw this at OWASP AppSec New York in November, and it just like blew my mind. So there's a group of people up at OWASP that are basically trying to create this periodic table, and it's supposed to look like the periodic table of elements, but instead of elements, they have vulnerabilities. So SI stands for SQL injection, and XE is XML path injection, and there's good versions of this online where you can hover over these things and sort of figure out what they are. The actual sort of cluster of types of applications, enumerating them, is not really as helpful as how they were categorized. Basically, this team sort of sat with all of the vulnerabilities they could possibly find and said, if we were going to fix this vulnerability, where would it be appropriate to fix the vulnerability? And you'll notice the massive vulnerabilities fall underneath generic framework. Right? So if you choose a good generic framework meaning something like Symfony or Django or Ruby on Rails, and all of those are considered sort of generic framework under this definition, you could potentially get rid of all of these vulnerabilities in your application. And the reason is the framework won't allow the developer to introduce those vulnerabilities into the application. With a good framework, in order to introduce like a cross-site scripting or SQL injection flaw, the developer has to intentionally write bad code, like basically bend out of the framework to write that bad code. And that's perfect, because increasingly we're seeing a lot of studies that show that you can send your developers to developer training to show them how to write good code and show them what happens with bad code, but 6 months later they forget, because the pressures of pushing real features out the door always come first, right? And so when you're trying to get your next release pushed out to market, you're not thinking, oh geez, did I remember to clean up all my cross-site scripting? It's just not on your radar. If you're using a framework that does it for you, you don't even have to think about it, right? So this takes the job of security away from the application developer, which is actually going to be successful, unlike other strategies where you have sort of like training and you force people to write stuff some way and you review it, and when they don't do it, you go back and you smack their knuckles or whatever. You'll see that perimeter platform is a pretty good chunk. So this is like sort of your infrastructure, your network, things of that nature. Browser standards, there's small chunks here, and there's movement going on here in the HTML5 space. So if you're using a good generic framework, your developers become responsible for some elements of custom frameworks and some elements of custom code. And those vulnerabilities over there typically are stuff like abuse of privilege. So that is it's entirely business process related vulnerability specific to your app. Like you've built an app that shouldn't allow user A to do something B, and you forget to not allow them to do that. Like you have to write custom code to do that. The other types of vulnerabilities they have is sort of insufficient anti-automation, right? Like if you let somebody just try and log into your app 300 times in 2 seconds and don't stop them, there's not a whole lot of framework can do for you. You actually still have to do that. But I think being able to approach developers and say, hey, these are the things we need to concentrate on, is going to be a lot more effective than say like, oh, well, it starts here, and basically you're responsible for somewhere in this neighborhood, right? And so that's the advantage of choosing a strong framework. You're eliminating whole classes of vulnerabilities from your concern. And you'll just get, when we started doing this, we saw a precipitous drop in the amount of incidents, but we also saw a precipitous drop in the amount of attacks. Like people just they probed our apps and then went away because there was nothing there for them to find. So what did we standardize on? We standardized on Symfony 2 now and Drupal for our application development. Those are both really big, robust. Drupal's a content management system that's become an application development platform, and Symfony is a totally custom framework. Our environment is PHP, MySQL, and Linux based, so we chose those two technologies based on the fact that all of our servers are running Red Hat Enterprise Linux and they've got PHP and MySQL on them. And in Philadelphia, we have a massive Drupal developer community. We have like a DrupalCon that happens every year, and like 300 people show up. So there's a whole lot of local talent to support us there. And interesting to note, before we actually made the choice to go with Drupal, we didn't have any Drupal sites. So we really did sort of a carte blanche. We sort of sat down and said, like, our web app security problem is out of control. We need to do something about it. Let's choose something, and we chose something that nobody had any prior experience in. And it ended up working really well for us. So after you've chosen your sort of framework layer, the next thing to do is adjust the way that your framework interacts with its native language, right? So every framework is going to be built on some other language like Python, like PHP, Java, what have you. And a lot of those languages have their own capabilities to enhance security. And they're often overlooked because normally when you're going into an application, you just sort of like, you're not really sure what the client wants, so you just kind of like want to leave all the doors open and leave all the possibilities there. But there will come a point when you stabilize an application, you say, you know what? This application is never going to request a remote file for downloaded local execution. We should probably turn off that feature. And doing this will dramatically increase the security posture of your applications as you push them out the door. So what we've done with this is we've customized our PHP INI. So we've actually disallowed whole classes of PHP functions. We've sort of said, look, we don't have any applications that use these functions for anything legitimate, so we're just going to disallow them. So that if anybody managed to take over our code base and inject some sort of malicious code, it just wouldn't work because the Apache server would not compile that code. We added a bunch of custom modules to our Drupal deployment. So we identified a bunch of security-specific modules, and we required them before we would launch Drupal sites. We said, you must have these following modules. We enforced safe data libraries, so we either chose frameworks or development models that made people use these, or we actually did line-by-line code audits, and when people didn't actually use these libraries or safe database interactions, we would kick the application back to folks and say, hey, you need to fix this before we deploy it live. And we have formalized security testing as like the last piece of our go live process, and we built in like a 2-week turnaround there, so folks who want to publish an application with us, they give it to the security team reviews it. Our security team are all developers though, right? So they don't just come back with a big checklist of red all over, you know, an application or whatever. They come back with the code that the developers wrote and they say, on line 47 here, you did this, here's my proposed patch that will fix it, doesn't look good to you guys. And that is the only way we've been able to get away with this, because then the developers feel like the security team is collaborative and it's sort of helping them find solutions rather than just throwing up roadblocks. So it's easy too when you're developing a web application to forget that although your web application lives on the web server, there are several different layers of the stack underneath that support the web application. If I say anything that sounds like totally crazy, feel free to throw up your hand and ask a question, or if you're bored or whatever, I just want to let you know, feel free to interrupt me. I'm looking for hands, so if you raise your hand, I'll call one. So, you know, typical LAMP stack, we've got 4 different layers. We've got the operating system, our web server, our dynamic scripting language, and our database. And each one of those has its own security countermeasures. But it's not very common that development shops or even infrastructure shops examine all 4 of those layers and say, are we doing everything we possibly could to get all the security we can out of these layers, right? All of the security countermeasures are built in here. Why not use them? Why not turn them all on? So, starting with the operating system layer, we limit file system privileges as much as possible. So the greatest threat to our web infrastructure is that someone manages to take over one of our applications and begin to execute commands as the Apache web process, right? So our sort of threat model is Apache web process is untrusted and could go haywire. What can we do to cut down on things that can happen with that? You could cheroot the whole environment and lock it down, but we haven't chosen to go that far. Instead, what we do is we limit very, very selectively where the web application or the web server can read and write on the file system. So in a lot of our applications, the web server can read all the files to run the application, but can't write anywhere in the directory. So even if somebody takes over your application and wants to drop some little PHP backdoor shell, there's nowhere for the web server to actually write that file. It just won't go anywhere. We also use host-based intrusion detection systems that basically do file system integrity and anomaly checking, right? So on some sort of regular period, they scroll through the web root, they look for anything that's new there. And if anything is new there that doesn't look like it belongs, it alerts somebody, right? And so you have to tune these things. If you've got some sort of application that allows users to upload photos, you're probably not going to pay a whole lot of attention to that directory. But if another directory on that application suddenly gains 3 new files overnight, that's probably something you want to take a look at. That's a sign that something has gone wrong. And that's like super low tech. Like that's a really easy check to write. And then the other thing that we do is we limit shell access and require secure connections. So wherever possible, we make all of our developers use key-based SSH, and that on the next side, to get access to the hosted environment. So nobody accesses MySQL unless they're calling through an SSH tunnel. We disallow remote root SSH access. We make everybody use public keys so that it's much more difficult to steal them or get them lost. We have a centralized OSSEC instance. Has anybody used OSSEC? So it stands for Open Source Security Host-Based Intrusion Detection System. It's a program written in C. It's super easy to install on your web servers. And what it'll do is it does active file monitoring. So it's got a XML-based list of rules, and it'll monitor all your files, including like your weblog files, but also your system message logs. And it'll look for anything anomalous. If it finds anything anomalous, it can send you an email, it can do an alert. You can even build in custom checks. You can write your own rules really simply, and you can configure it to do blacklists. So if you see somebody that's just requested 3,000 pages from your website, and they were all like 404s not found, you could actually just blacklist that person at the firewall level and say, you know what, this is not like that person just gets the emo. I'm not going to want them here anymore. Super easy. It's totally free. And then, as I mentioned, we try and limit where all the web server can actually write. The other thing that we really try and do is isolate our web server. And I don't just mean isolate the web server from the other components of the infrastructure, but also isolate servers from one another. One of the things that we do when we look at a new application is we try and determine sort of the criticality of the data that the application is handling. And we try and tier web servers so that each web server will contain applications that have the same kind of data characteristics, right? So we don't have a web server doing, processing our credit card numbers next to a web server where people can post their funny cat pictures. Like those are two totally distinct things. And we have developed sort of like a method for measuring the criticality and sensitivity of our data. We have a standard document that's posted, and so we look at these applications before they come online and say, based on the profile of this application, where should it go? And we always try and put it in an area that's just as secure, because what you don't want to run into is a situation where somebody compromises a really low-value web application that doesn't have any sensitive data, and then uses that compromise to leverage access to a really critical web application that does have a lot of sensitive data. So you want to keep those two applications totally separate so that they can never cross-contaminate. You also want to limit the privileges of the server process itself, right? So if Apache or whatever IIS goes nuts, goes haywire, what all can it do? Can it negatively impact the overall health of the system? Can it read and write files that it shouldn't? You want to try and limit that as much as possible. And yeah, ensure uniform data sensitivity across. And virtualization really helps with this. Like if you have access to a virtualized infrastructure and you develop a new app and you realize, wow, this is actually really sensitive, it becomes very easy to just sort of spin off a new virtual machine and isolate that very sensitive app in its own sort of sandbox away from your other apps. So that you don't have any of these compromises that just go haywire. I mean, most of the big compromises that we sort of saw a couple summers ago when WellSec was going nuts with the anonymous kids, I mean, those were sort of like not very important web applications that were getting popped, but they were all connecting to a database full of just troves of super sensitive data. And so you had these applications that I'm sure when somebody did a security assessment, they said, well, it's not super secure, but who cares? It doesn't have anything useful in it. And they just never put two and two together and said, okay, well, if somebody uses this web application to leverage a foothold, something really bad can happen. So one of the solutions that we've done, especially with Drupal, which has been really neat, is we have one Drupal instance running, I think, like 300 different Drupal web applications, which sounds a little crazy, but basically we're throwing all our eggs in one basket, and then we keep very close eyes on that basket. It's very difficult for anybody to change that code base because it's centrally managed, and we like watch diffs and things like that. We use Git to push new changes and things like that out of there. And we've actually sort of cut down on, a couple of years ago, we had, each custom-built application had its own sort of bucket of code. And being able to audit all those buckets was just a mammoth task. Like, there was no way we were going to be able to go through all that code and make any sense out of it. And by forcing everybody to use the same framework that had a monolithic architecture, we said, okay, everybody's using this code, you just go extend it. And now all those baskets that used to have like full application stacks just have little bits and pieces of code, just modules and extensions that allow them to use the central monolithic framework in the way that they want it to. And then they're custom templates and stuff like that. So then when you go and do a security audit, you do a really good job on your monolithic code, and then the smaller pieces of code become a lot more manageable. We also make sure that the developers can't change that code base. It's sort of frozen. We have a very difficult process to update it and change it. And the application server, as I mentioned before, we modify our PHP config, so it runs with very little privileges. It can't really do anything other than what it's strictly intended to do. And then if we have applications that just stray really far out of this model, or somebody's very insistent that they have their own unique snowflake and it needs to go somewhere, we use virtualizations to solve that problem. And the key to spinning up virtual servers for these kinds of applications, like a one-off application where someone's like, I want to do this crazy thing, and you're like, it's not going to fit in here, but we'll give you a virtual application. You need to set a strict expiry timeline on that project. Like, you need to say, like, we'll do a virtual machine for your application, but in a year, we're going to come back and review it and potentially take it offline. Or will you commit to taking it offline 6 months from now? We've found that it's been really helpful to use Amazon Web Services for that, because you get charged every month. So we sort of say, like, okay, well, you want your special thing, we'll put it up in AWS, and you'll get your first bill the first month, and they say, well, we only need it for 6 months, and sure enough, month 7 rolls along, they get the bill, and they say, actually, we don't want this anymore, take it down, and you're done. Which really sort of gets you out of the problem of deploying these crazy applications and then just having them sort of fall off the edge of the earth and everybody forgets about them until they get compromised. Don't ever forget database security. I guess there are more and more people who are like sort of building web apps using very lightweight databases like SQLite that really don't have a whole lot in the way of security. But if you're using any sort of monster like MySQL, MariaDB, Oracle, MS SQL, there are a ton of security features in all those databases, and most people don't use any of them. I'm shocked even when I find applications that people deploy, on MySQL, and the application is running as the root user with no password, because that's the way it's installed by default. I mean, I understand it's easy, right? Like, that's why people do it. But there's a whole lot you can do inside your database layer to do things like segregate privilege, right? You should create unique user accounts for all of your applications. Sometimes more than one user account for an application. You should limit least privilege, so you should take away any privileges that your application doesn't actually need. If your application doesn't have to write files to the file system, don't give the application the right to do that. If you can, make separate databases for every single application at the very least, and then try and have those user accounts tied to databases. That way, if one user account gets compromised on one database, you're not going to lose data in other databases. You can turn on all sorts of transactional logging, and this is awesome if you do have a compromise, because then you can go back and say, yeah, I've got like 12 gigs of transactional logs from SQL logs from my database, but I know exactly what the attacker did. I can see the exact queries they manipulated and exactly what data they pulled out of the database, which can make a huge difference between like a terrible, terrible compromise, oh my god, they got our entire database, or actually we only lost 12 records. It really wasn't that bad. In addition to that, if you can make use of stored procedures or parameterized queries, I mean, I've written these. If anybody's written these, they know the hassle around them, like it's kind of a pain in the butt. A better idea is to use an object relational model, an ORM, which will just do safe database interactions for you. Again, this kind of thing takes the safety and the vulnerability away from the developer, so you don't even have to worry about it. And whenever possible, don't allow your database to be accessed remotely. Make sure all of your connections are local, and you just have, people are like, well, I need to connect. Just use an SSH tunnel. Just SSH to the machine, do your work locally, and then connect off. If you're going to allow remote DB connections, generally those are going to be between machines that are close to one another at your data center, and just make sure that those pinholes are very narrow on the firewall, so that only those machines, like the primary machine and the database replicator can speak to one another over a non-SSH channel. So what we do is when a developer starts an application, basically they come to the database administrators and say like, hey, I want an application. And our default mode is for the database administrators to provision 2 accounts. One is the developer account that has pretty much every privilege they want. You know, create tables, drop tables, alter tables, so on and so forth. And then they give them an application-specific account that doesn't really get any privileges. It gets read, write, you know, update, delete, and that's it. And then the developer will go and create the application using his account, building tables, tearing down tables, testing things, and at a certain point they'll swap out their account for the web application account and see if everything works. If it doesn't work, they'll tweak and adjust the privileges, but by starting that second account with such low privilege, it ensures that when the application goes live, it really can't do anything more than it was designed to do. And this is super helpful because you can really mitigate a lot of problems with, you know, terrible SQL injection just by saying, well, the account that's being used here really just can't do that much. It can't see the user table. It can't select passwords. It can't select credit cards. It can add new ones, but it can't pull old ones out of there. You know, you can really sort of cover a lot of bases there. We even do some stuff where we obfuscate the connections for the passwords in code. I'm not really sure how much this helps. I think a dedicated attacker who managed to get a copy of your code base and found like, oh, you're like hashing your password, but I know how to unhash it. I just have to figure out where. I think they're going to get your password. You're going to make them mad. So I don't know about that, but I don't know. Some things people insisted on. We do use stored procedures for very sensitive functions. So if we have some functions that like potentially could go very, very awry, we just compile them up and use them as stored procedures. Most of the queries that we're using are not stored procedures, but if there's some things that, you know, it's a university that has to drop in and like touch 10,000 students' grades, that is always a stored procedure so that we can audit it and test it and that kind of stuff. And a database access is always over SSH. The other thing that you want to think about is training your people. And like I said, your mileage may vary with this, right? If you have a super secure framework that you're working with, your developer training might be very minimal. It might just be like, make sure you use this stuff in the right way. Like, don't ignore the warnings in the code documentation that say, like, don't do it the wrong way. You should sort of establish some sort of secure coding baseline. So your developer should be aware of, like, what is sensitive data, what is non-sensitive data, how should we treat the two, when is the work that I'm doing you know, falling into the purview of security, and when is it just pure functionality, right? A lot of times developers don't even realize that they're working with like sensitive libraries or data structures or functionality in an application. And that's where you get the problems because developers won't understand the security risks and so they won't really apply extra diligence in those particular areas. You should use sort of a standard set of tools and libraries. Choose those for your group and make sure that everybody knows about that too. I think the more that we as a community sort of publish, like, these are the tools that we're using and they're good, the more we'll get support for those projects and the more people will invest effort into them and make them stronger. And then make sure that all of your applications meet whatever baseline you set before you deploy them. Like, don't let them slip out the door. And this can be a really tricky one because oftentimes that involves some politics that sometimes fall above the pay grade of most developers, so there really isn't a whole lot you can do, or security people. The way that we sort of get around this is we commit to provide full lifetime support for an application if it clears our security baseline. So we basically tell our clients, if your application that you want us to deploy meets all our security baselines, passes all our intensive security review, not only will we host it, but we'll commit to support you in that application until you want to terminate it. And so that carrot and stick seems to work pretty well for us. Again, training can help, but you really want to have an environment where the only time you get vulnerabilities is when a developer deliberately puts them there. Not necessarily maliciously, but maybe just mistakenly. But you want to be able to look at code that's vulnerable and say, geez, why did they do that? Like, I don't understand that. Rather than looking at code and saying, well, there's a vulnerability here, but I can't see it. That's the opposite of what you want. So we're involved in a constant push of, to refine our platform. So we do proactive security reviews of all of our platforms, Symfony, Drupal, any third-party modules that people want to plug in. We work very closely with a lot of software developing firms, reporting vulnerabilities to them, helping them fix those vulnerabilities, getting our platforms safer and and more secure. We publish our coding standards so that when we have third-party developers who come on board and are like, hey, we want to do a job for you, we can point immediately to this document and say, this is going to save you a lot of headache, just read this first. And we've trained a number of developers to actually do code-level security reviews. Finding people who want to do this can be a little bit tricky, but if you find the people that are like really excited about it, they'll be awesome for you, right? Like if you can find the 1 or 2 super enthusiastic people who are like, I really want to find SQL injection vulnerabilities inside code, and you can point them towards your code and allow them to find those vulnerabilities, it'll be very exciting for them, and the rewards will be tremendous because basically you're going to have in-house QA from a security perspective, which should just be awesome. And then, we try as much as possible to vet all changes in live applications before they go live. So we try and apply our same sort of security review model after an application goes live. So the developers come in and they're like, hey, I've got all this new code. We make them submit all that code to us. We do a review of it again, and then push it out, make sure it meets our coding standards and our automation, and our guidelines, sorry. So I hear a lot of people talk about automated tools when they speak about web application security, and they're talking about like, oh, I run Nessus or some other commercial scanning tool, and my web apps all come up good. And you should definitely run automated tools against your applications. You should recognize though that your automated tools are terrible. They're really bad. Their hit rate for true positives is really low. They normally will flag a whole bunch of false positives, which will be very frustrating because they'll report a whole bunch of vulnerabilities that don't really exist, and you're going to have to sift through them. What they will find is the really low-hanging fruit that the script kiddies on the internet will find in a couple months. So they could save you that headache. But really, to have a good test, you're going to need a person to test your applications. You're going to need a knowledgeable person, not just a person running the tool who doesn't know what they're doing. You're going to need somebody who's probably familiar with your application development cycle, with your workflow, with your environment. And that doesn't necessarily have to be a dedicated person. A lot of teams will just sort of go and tap somebody who says, hey, I'm interested in security, and sort of say like, okay, you're the security person now. Now it's your job to go ahead and start poking at our stuff and seeing if you can find tools. And I have friends who work at some really big startups who have managed to find people like that. The next week they've just got, some self-motivated employee has gone home and found like 500 cross-site scripting vulnerabilities in their like e-commerce application, which is a horrible hassle for them to fix. But how great that an internal employee went and took the initiative and found all of that before somebody else found it and either used it for malicious purposes or broke in or anything like that. I'm a firm believer that anybody that you want to make responsible for security, especially in an application security realm, they need to be an application developer first, right? I don't think you can take a security person and teach them to be a programmer very easily. That is not impossible. It is possible, it's just hard. After you've programmed, you sort of understand a lot of the fundamentals of how code works, and it's very easy to sort of talk to a programmer and say, okay, like, here's how things go wrong, because you already have the paradigm, you understand that. And so this is like my favorite example. These are just 2 pieces of Python. One of them is vulnerable to SQL injection, and one of them isn't. It's like, who remembers the difference between percent or comma in the parameter data? I've got one.
The first one is string format?
What's that?
It's a string format?
Yeah, they're both string format, but one of them will sanitize it.
The second one?
I don't know. This is like, I'm not a Python programmer, so this is like one of these things. It's like, if you did this every day, you would instantly know. You'd be like, oh, you wanted to do this, not that. But to a full-time security person, they have no context to even remember. What they would have to do is say, every time I find some sort of parameterized statement in Python, I need to go back to the manual and remember, like, is it a comment or is it the first argument? I forget which one. And I honestly don't remember off the top of my head which one is vulnerable to SQL injection, but one is, And like even just glancing over this code, it's not immediately apparent that anything's going wrong because it is actually parameterized, right? You actually sort of parameterize your variables. So in terms of the tools that we use in my shop, we use we use all open source tools. You'll sort of know we have absolutely no money. So all our stuff is open source. So we use W3AF, which is a really aggressive web app penetration testing tool that will just chew through a lot of resources and show you way much more than you ever wanted to know, but it's a really good tool. The OWASP attack proxy is a super good tool. It has its own automated spiders. It'll do its own automated testing and mapping of your service. It'll look for cross-site scripting, SQL injection, you know, the whole OWASP top 10. Honestly, it's my favorite like fully automated tool. And then it's got a mode where you can just sort of use it as a proxy and browse the web and do stuff, and it'll record what you're doing, and then you can later back up what you were doing and sort of change your inputs and stuff and replay attacks and things of that nature. If you haven't played with OWASP app, I would highly encourage you to go download a copy and just check it out. It's a lot of fun. We use the Firefox Tamper data plugin because every time I find a form field, I want to put, you know, malicious control characters in it, and that just makes it a lot easier. We use Eclipse for all our code review. I'm a big fan of, like, you find a problem, try and find out how to fix it. So we're huge at staring at source code in Eclipse. And then we've got a couple custom Python scripts that mainly just sort of grep through code and look for like known dangerous functions. I mean, if you Google like language name dangerous function, you're going to find a list of like stuff that people tell you not to use, but you are probably actually using mistakenly in your code. And just having a little script that'll run through all your code and say like, oops, say you use that super dangerous function, you better go back and triple check and make sure that you used it in the right way. That can save you a lot of headache down the line. So far I've sort of talked about preventing compromises, but there's a whole other side of this coin, and that's just detecting compromises, right? So we can do all we can do to protect compromises or prevent compromises, but the reality is we're basically playing a guessing game with an unknown attacker, right? We're basically trying to outthink somebody that we have no idea who they are and what their motivation is. And we're basically trying to think, well, they might want to do this, so I'm going to keep them from doing that. They might want to do this, so I'm going to keep them from doing that. Realizing that there are really severe limits to doing that, you might want to think about like, okay, let's assume some evil genius bad guy thinks of something I never thought of, breaks into my web app. How am I going to know that happened? And that's where detection comes in. What kind of logs does your application include, right? When you're writing an app and somebody fails a login, do you ever log that somewhere? You know, if your cross-site request forgery token doesn't validate, do you ever log that somewhere? Somebody submits the same form 50 times in under 2 seconds. Do you ever log that? And these are the kinds of things that application developers can bake directly into their application, especially if they can get those logs somewhere centrally, right? So on a Linux or Unix system, you pipe that stuff to syslog. You can then use tools like OSSec, which just monitors syslog, and write rules to say like, hey, my custom application is burning up. Like, what's going on? Alert some of the security guys. We sort of talked about it earlier, but you know, auditing file system changes is a really, really helpful thing to do because you can tell if, you know, you got extra files, you know, like evil.exe showed up in your web root, or if your web root consists of one file and it's called like you've been owned.txt, like equally worthy of being notified. Scanning uploaded files for malware, like just if you find new stuff on your web server, why not just like run through ClamAV or something? Like you can free malware. Like, hit rate is usually terrible for desktop malware, but you would be shocked at how much like server-specific malware gets picked up by this stuff because the guys that are using it never change it, and it's all like uncompiled Perl scripts that start IRC bots and stuff like that. So it's an easy way to find that. Again, you want to build in logging into your application, and you want to perform some sort of automated log analysis, right? Like it's all good to be having your application producing like megs and megs and megs of log. You never want to look at that. And maybe post-compromise you want to look at that. You mainly want to set up some other program that scrolls through those logs and does anomaly detection and notes like, this process doesn't normally log this much at, you know, in this type of time interval, something's funky. Or, you know, like you can have OSSec say like, it looks like somebody just tried to brute force their way in through the login screen, or somebody just tried to, you know, move $100 from their account to somebody else's account like 50 times in 2 seconds. Like that's not legit traffic. All of that can give you a lot of visibility into your application and can help you to spot not only when there's a compromise, but also when something's going wrong. Like this is an easy sell for sort of customer support too, to sort of say like, you know, it was always my favorite when I was doing web application, when I get the call from the irate client, they're like, your web app, and I was like, yeah, I know I'm working on it already, you know, and you get to hang out. This is the kind of strategy that will help you do that. So, like I said, we use OSSec and ClamAV. Those are our pretty big ones. OSSec, this file integrity monitor, is very similar to Tripwire, which is an older sort of tool. All it does is you tell it which directories to sort of monitor, and it'll just run through a MD5 hash sum of all the files. MD5 hash changes, it'll alert you that the MD5 hash changed. It's really lightweight, goes off in the background, and you can send alerts via email, I think even SMS and stuff like that now too, if you're feeling really bold. So, and sort of the last pieces to this puzzle is being able to recover quickly, right? So you did discover that your website got compromised, everything's gone or everything's wrecked. what do you do there? Like, is your response process, does it involve calling everybody in on the weekend and going through backup tapes and painfully trying to carve out the pieces that are supposed to be where they are and migrating them back into the live site? Or is your backup process, you just do another git pull and you just pull a new copy of all the code and wipe out all the old stuff? How good are your backup processes? Do you test your backup processes? Like, do you run through exercises where you say, like, okay, let's just pretend everything got blown up. How quickly can we put it back together? All of that is really, really important. And I've actually seen compromises defeated where teams would just constantly refresh their code base. And so even though the attacker could actively manipulate their code base, the code base wasn't stable long enough for them to actually get a foothold. So like basically they'd break in, get kicked out, break in, get kicked out, break in, get kicked out. And they just put it on this loop and took their time figuring out how they were going to actually solve the problem, but frustrated the attacker long enough that the attacker never won. So the tools for this are super simple. It's probably stuff you're already using, you know, your regular tape backups, CVS and Git for your version controls. We have separate staging, development, and production environments. So we have like a full Git repo for all of our production environments. So if our production environment went crazy haywire, we just pave right over it with a new copy of our production environment. And we have totally automated deployments, right? So what you don't want is somebody at 2 in the morning logging in remotely when they're slightly hungover trying to remember all of the Git commands to get rid of the old stuff and push the new stuff, right? You want a simple script that just says like repave, and all they have to do is /repave, and it's done. And that is the kind of thing that you want to test. You don't want to have any potential for human error when you're doing these kinds of things. So that's pretty much all I got. These are my conclusions real quick. You know, I will let you read them. I won't repeat them. But yeah, you know, it's pretty simple stuff. And I think you'll find that you'll be able to adapt a lot of this stuff in very unique ways to your environments that will probably make it a lot more effective than like taking my suggestions. So I don't know. I'll take questions if anybody has any. Yeah.
Thanks. It's very helpful.
Sure.
I didn't hear you mention WAFs at all, actually.
I hate WAFs.
Okay. Why?
Well, I mean, on principle, I feel like a WAF is just paving over a problem. It's not solving it. And I understand that you can get some short-term benefit with a WAF, but I think it's a bad strategy for most people. There are cases I'm aware of where you have a really bad flaw, it's being exploited, you need to fix the problem, you know, just right now to band-aid it until a real fix comes out. In those situations, it's fine. I'm not convinced that there wouldn't necessarily be other cheaper, better, more effective ways in many circumstances. I know that people have WAFs in their arsenal. I don't really recommend them. I think if you do your work going in, you're not really going to have to worry so much about that. I think the main audience of sort of WAFs for defense is code that is legacy and it's not maintained and it's difficult to get developers, or it's like really production critical and it can't get changed. I don't work in any of those environments, frankly, so I don't, you know, there may be very legitimate use cases in those environments that I'm just not aware of. But because I tend to work in environments where we insist on like modern, patched, up-to-date, reviewed code. If there's a problem, you know, again, we are all open source. We just drop in and fix it right away, rather than trying to hassle with a WAF.
If you don't mind, just for context, what makes the university such a big target?
Our bandwidth.
Okay.
Yeah. My computer plugs into a 10 gig Ethernet port. And I'm just one of like 16,000 computers on campus. Yeah, we have massive, massive bandwidth. That's really it. There's nothing really other. I mean, I don't know. The U.S. government.
Actual sensitive information.
You know, the U.S. FBI and Department of Homeland Security comes by occasionally, and they're like, the Chinese are stealing our nuclear secrets or whatever. But like, our nuclear scientists are all doing open research that they present at conferences anyway. So I'm not buying any of that. So we don't really see much in the way of intellectual property theft. Mostly we see people breaking in to get control of the machines that have the bandwidth that they want. Or, I should rephrase, the other thing we see is our customers get attacked, right? So like the students and the faculty and staff, they're getting their bank accounts, so it's not, there's no institutional risk there. So professionally my job is like, oh, that sucks, but it's not, I'm not supposed to protect you from that. I mean, we see a lot of that, for sure.
And I want to hop the conversation. One more question. Do you guys, you implemented measures to stop attacks before they can even be possible, so at the code level, and so But, and you try to detect attacks as they come. Do you actually care much about like an attack as it's progressing, where is it coming from? Like, is there a high level of intelligence?
Yes.
Okay.
Yeah. So we run an entire security intelligence framework. It's actually open source. It's called Hector, that we built in-house that uses our intrusion detection system logs. They use our darknet sensor logs. We've written a bunch of honeypots, so they're all Python programs that mimic live servers that allow attackers to break into them. And we use those to sort of fingerprint post-compromise behavior. Like if somebody broke in successfully, like we're making them like think they did, what kind of things would they do? We do a lot of that, and we aggregate all of that along with, we have an incident reporting mechanism. So every time we have an incident, we do an after-action write-up, and we sort of put all of that data in a database so that we can sort of draw parallels and say, you know, like, are incidents mapping to the malicious traffic that we're seeing, and is that mapping to sort of our honeypot data, and if not, why not? Like, where are the emerging trends? You know, are there vulnerabilities showing up that are making things change in this landscape, and that kind of thing. So, yeah, we are actually pretty proactive about trying to figure out, because, you know, you can have a perfect program like this and nothing to do as a security person, you know, and it's sort of irresponsible just to kick back at your desk and be like, I'm done, you know, so we kind of reached a point where we weren't having any more attacks, and we wanted to wonder, you know, we wondered, well, what's happening? Like, why aren't we having more attacks? Are they not happening, or are they just happening in different ineffective ways? And so we went out and began to look at our network and sort of deploy servers that looked like they were vulnerable to just see what was happening. And we went to look at our incident reports to sort of compare annualized how our web application incidents were comparing to everything else. And so that was also very helpful to go back to management and sort of say, like, hey, we did these things and our web app incidents have plummeted, and now we've got malware desktop infections flooding our ticket queue.
Thank you.
Yeah.
I'm not an expert and I don't know anything about what I will talk about.
Don't worry.
Yeah, I just wanted to know if you're more aware than I am. Okay, I heard in the past that maybe the most secure operating system would be like OpenBSD. Do you know anything about that, or is it still true, or is it not anymore so true?
It's so hard to say things like that because nobody ever just like has OpenBSD, right? Like you install applications on top of OpenBSD, and you connect it to an infrastructure, you start doing transactions with other systems, and your sort of security posture changes pretty dramatically on implementation. I don't have any particular favorites in terms of operating systems being like more secure or less secure. For me, secure comes down to how in control I feel of the operating system. So I tend to use Linux because I feel like if I worry about something, I can go find the code and read it myself and put my mind at ease. Or if something's not working right, I can just go and change it. It's not closed source operating systems frustrate me because I always feel like I run the risk of a security flaw that I would never know about. And who knows if the company would ever disclose that to me as well. And it's not to say that they're any more or less secure, it's just my appetite for risk is different in those environments because it's not risk that I can mitigate. I can't read the code, I can't have somebody else read the code, I can't trust that, I just sort of have to put my faith in the vendor that everything's okay. So I think there's where you get in a lot of arguments with like BSD and Unix being more secure than like OS X or Microsoft Windows, but yeah, that's really tough. I don't, more secure, less secure, who knows?
But it's not a topic that somebody talks about like, okay, here's the track they are following and it's a good direction, yes or no, you are not aware of what they are doing?
It's not really, I'm aware of people who make claims. I'm not aware of much in the way of substantiation of those claims. Are you?
But which one do you use? You use just Linux, and if so, which distribution?
I use Linux except for my laptop. I use Mac because I'm so sick of having to recompile wireless drivers every time I travel.
Is it Ubuntu or something like that?
No, I use Fedora because I use Red Hat at work, so the subsystems are very similar.
Okay.
But yeah, I'm totally comfortable with any Linux.
And when you do hardening, because I think you mentioned some OS hardening or or something like that, or maybe segmentation or maybe virtualization. You didn't precise it, I think, but so that
what are we using for our virtualization and stuff?
yeah. Well, why not virtualization? Because you spoke about, you know, like doing the maybe segmentation of the HOSs. And what kind of tech do you use for that?
Well, so the most so if you're not segmenting based on like the actual installation, like the virtualization, we're just using like user permissions on the file system.
Okay.
So